Okay, here is a video on blocking probabilities, and this is intended to help you with the recent homework assignment. And I hope you'll see that doing the problems in the homework assignment is relatively straightforward once you have a few of these equations mastered. So what we're interested in is we're interested in the reliability of a link. Okay, so we've got a link from point A to point B, and we're interested in the probability that you can make the connection from point A to point B. Okay, and there are a couple different ways we could approach this. We could ask ourselves, what is the probability that the link is open between point A and point B, or we could ask ourselves, what's the probability that it's blocked? So, and of course, it's either open or blocked. And so the sum of these two probabilities is 1. Okay? So it's certainly one or the other, and they're mutually exclusive. So, and so we have a choice of working with either of these quantities. And it turns out we're going to choose to work with the blocking probability. And solving this for the blocking probability, we can write this as 1 minus the probability of open. Okay? And we'll just use P sub B for the blocking probability. The B stands for blocked. Okay, so that's the first thing we're going to do. So this is the probability that the link is blocked. Okay, and now the question is, let's consider some more complicated situations rather than just this single link from A to B, and let's, for example, consider the case of parallel links. Okay, and so we're interested in going from point A to point B over the possibility of having multiple paths between point A and point B. So here's an example of two different paths from point A to point B. And let's assume that each has a blocking probability. The first path has blocking probability P1, and the second path has blocking probability P2. Then what is the blocking probability from A to B overall? Okay, if we were to just view it as a single link from A to B. Well, it turns out that in order for the link from A to be blocked, we have to have both paths blocked. Because if only one is blocked, we can take the other one, and so the link would be open. If both are unblocked, then clearly the path from A to B is unblocked. If either one is unblocked, then the path to A to B is blocked. The only way we can have a blocked path is when both links are blocked. Okay, so P block is equal to the probability that both links are blocked. Okay, and this is the product of the two probabilities P1 times P2. This is very much like when you flip a coin. When you flip a coin twice, what is the probability of getting two heads? Well, so for example, the probability of getting a head and then flipping the coin again and getting another head is 1/2 times 1/2. That is a probability of 1/2 that you get the first head, and times the probability of 1/2 that you get the second head. Okay, so this is the basic rule of probability theory, is that you multiply probabilities when you need for both of them to simultaneously occur. And so this is a simple case for parallel links. If we have n parallel links, what we're going to do is we're going to let P sub I be the blocking probability, of link I, where I runs from 1 to n. The n is the number of links we have. Okay, so I is the index of the link probability. So we had P1 and P2 here. Then the probability of a block in this case is P1 times P2 times ... Pn, or written in summation or product notation, the product from I equals 1 to n of the p sub i's. Okay, and this is the n parallel links case, where we have from A to B our first link, our second link, all the way down to the nth parallel link, P1, P2, Pn. Okay, and so this is the case where we have the link from A to B being made up of parallel, 2 or more parallel links. And in that case, the blocking probability is simply the product. In the next video, I'll talk about series links, and we'll see you there.